Hi, all. Good morning. Today's topic is simple harmonic motion. Simple harmonic motion is shortly called as SHM. So today I am going to cover three topics: definition of simple harmonic motion, conditions of simple harmonic motion, and we are going to show the projection of uniform circular motion on any diameter of circle is simple harmonic. So we are going to cover three topics. So this is the basic topic to understand the forthcoming video lectures. So keenly observe, please. So simple harmonic motion definition. Before we go into the definition, now I will tell you the conditions of simple harmonic motion. Simple harmonic motion should be periodic. Simple harmonic motion should be periodic. It should move to and fro. The particle should move to and fro about the mean position. And the acceleration of the particle is always directed towards a fixed point. Acceleration of the particle is always directly proportional to the displacement of the particle. Acceleration and displacement, they are always opposite to each other. These are all the conditions of simple harmonic motion. So out of these five conditions, by combining these two conditions, I am going to form a definition. Simple harmonic motion is the motion of your body such that its acceleration is always directed towards a fixed point and is directly proportional to the displacement. This is called definition. So what are the examples of simple harmonic motion? Simple pendulum. In the lab we are using simple pendulum. A sphere tied with a thread. We are oscillating it, so it moves to and fro. It is called example for simple harmonic motion. Pendulum clock is also example for simple harmonic motion. So in the concave surface, you are placing a ball at the one end, it will move like this. So it is also example for simple harmonic motion. Motion of a needle of a sieving machine. The needle moves up and down. It is also example for simple harmonic motion. These are all some examples. Now, first point I have told you, simple harmonic motion is always periodic. Yes. So don't think all periodic motions are simple harmonic, because simple harmonic motions are periodic, but all periodic motions are not simple harmonic, because planetary motion is periodic, but they are not simple harmonic. So all the planets revolving around the sun at one of the foci in the ellipse, but every planet, for example Mercury, if you take Mercury 88 days once it covers one round, and you are taking other planets, Jupiter and everything, so month wise some planets are covering the distance, and yearly once covering the distance. So they are all covering the distance, but it is not moving about a fixed point. They are all making the round in the elliptical path. So all periodic motions are not simple harmonic, but all simple harmonic motions are periodic. That is the main difference. You please keep it in mind. So then we will come to the expression part. How to prove projection of uniform circular motion on any diameter of a circle is simple harmonic. So let me consider this diagram. This is a reference circle. By taking this circle as an example, we are going to study. So this is the horizontal diameter x prime. This is the vertical diameter y prime in this diagram. So y is the origin, center of the circle. Suppose particle P is starting from the point x. Suppose, I will tell you one by one. If it satisfies the conditions, then it is assumed to be proved. Projection of uniform circular motion on any diameter of circle is simple harmonic. So how it is going to satisfy the condition, I will tell you one by one. So when the particle P starts from x, when the particle P starts from x, the projection N starts from O. So for the particle P, the projection is N. So when the particle P reaches the point P after a particular time t, the projection also reaches the point N at the same time. So when the particle P reaches the point Y, the projection also reaches the point Y. So second point, particle P reaches the point Y from X. Then the projection N reaches the same Y point. So from y to x prime the particle P travels. The particle P travels y to x prime. But the projection N travels from y to O. O. Projection n travels from Y to O. Next point is when the particle P travels from X prime to Y prime. Particle P travels from X prime to Y prime. The projection n travels from O to Y prime. O to Y prime. Next point, when the particle P travels from Y prime to X, the projection n travels from Y prime to O. That means as the particle P completes one revolution, the projection n completes one revolution, one oscillation. So when it completes one oscillation, when the particle P completes one revolution, the projection n completes one oscillation. So the period of as the particle P completes one revolution in the circle, the projection n completes one oscillation. So we can say the period of revolution of the particle P is equal to period of oscillation of the projection n. So based on this concept, we are going to derive the expression for displacement, velocity, acceleration, time period and frequency in the forthcoming video lectures. So now from these points we have proved the projection of uniform circular motion on any diameter of circle is simple harmonic. Why? If we imagine a particle in the place of projection, then it executes simple harmonic motion. So by having this fixed point, it moves up and down. So now we proved the projection of uniform circular motion on any diameter of a circle is simple harmonic.